In this lecture, we'll be discussing some very basic chemistry principles that underline biology, and I'm going to cut it down to just some bare minimum things that you need to know, all of which should be reviewed from some chemistry class, but it should be very simple details. So chemistry is the study of matter, and matter is anything that occupies space and has mass. And the building blocks of all matter are atoms. Atoms are made up of subatomic particles. The three types of subatomic particles are protons, neutrons, and electrons. Protons and neutrons are found within the nucleus of an atom, and the electrons float around the nucleus in these clouds and are basically the subatomic particles that are involved in chemical bonding. So if we look at just some basic pictures, you've got the nucleus here. There's all these sort of different graphics that you can look at, but you have the nucleus here at the center where the protons and the neutrons are, and then the electrons are outside on these rings. We now know that there's a pretty complex called quantum mechanical model where there's clouds of probabilities where electrons exist, but that's not really important. So all the elements that exist are on the periodic table, and atoms of the same elements share the same atomic structure and the same chemical properties. So any atom, like any sodium atom, is going to have the same number of protons. The protons define sort of what atom you are. Hydrogen has 1, sodium has 11, carbon has 6. But their arrangement of their electrons, it determines their chemical properties and how they combine with one another. So atoms combine in order to form chemical bonds in order to achieve stability based on the numbers of their electrons and how they interact. They can do this by sharing electrons, they can do this by exchanging electrons. But they all result as, because of sort of this electrical interaction of the subatomic particles, specifically the electrons. In biology class, we say molecule, 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 everything's a molecule. And the reason why is chemical bonds where electrons are actually shared with one another are called molecules. And they're made by covalent bonds, which covalence means they're sharing their electrons, as opposed to ionic bonds, which are when we exchange electrons. But most chemical compounds that we're talking about that are biochemical compounds are considered molecules. So when we see a chemical or a bond expressed, we use a chemical formula, and it tells you what elements are in the compound and within what ratio they are. So some common, you've got water, H2O, 2 hydrogens per oxygen. You've got sodium chloride, 1 sodium per chlorine. You've got iron 3 oxide, 2 irons per every oxygen. So the chemical formula tells us the ratio and the combination of elements within a compound. Now, the written formula like that is the molecular formula, but also quite often in biology we see structural formulas because the shape of things is important to how they interact with one another. If anybody's ever taken organic chemistry, you spend a huge amount of time learning about the arrangement and the shape of carbon rings and carbon chains. It's incredibly exciting. But just know that when we look at this kind of compound, or we look at this representation, what this ring means is this is a ring of carbons. So again, we're just looking at a large structural formula of a molecule. And all of these here, too, are bonded then to hydrogens. So in organic chemistry, you learn about carbon-based life. So just keep in mind when we look at bigger things like lipids and proteins, we're talking about sort of strings and arrangements of carbons and hydrogens and oxygens. And really their shape and the way they come together is important in how they behave and interact with one another. All right. So a cell functions by undergoing chemical reactions, and a chemical reaction is when one or more substances changes into new substances. In a general chemistry class, you learn about all these different types of chemical reactions. For biological purposes, we really only worry about a couple types of chemical reactions. I'll talk about them in a second. So in a chemical reaction, you have reactants and you have products. Reactants are what you start with. Products are what you make. So the two types of chemical reactions that we're really worried about in terms of biology are combination or synthesis reactions. And this is when you put two things together. So you're building something. And this requires an input of energy. Now, it could be creating like a peptide bond, okay? Or here, this just shows an example of like burning magnesium wire. So magnesium plus oxygen, you're making magnesium oxide. So it requires an input of energy, so energy in. And if you look at some chemical formulas, this really isn't that important. You see that when you build something, you start with more than one reactant and you build one product. But what's important to note is an input of energy or a storage of energy in a chemical bond. Then the opposite of that is a decomposition reaction. So a decomposition reaction is when you start with a substance and then you break it apart. And when you break it apart, you break a bond and it releases energy. So in terms of biology, we want to think about chemical reactions that we're going to be talking about for this course in terms of energy input and storage or energy leaving to do something else. Okay, or energy being released. And if you look at this, the examples of these are just the opposite of the synthesis reaction, because you're starting with one thing and then you break it apart into two. And a lot of times when you see this, you'll see like heat or something over here, some form of energy is released, and therefore then can be harnessed for something else in the cell. So just very, very simple. We'll just keep it in terms of synthesis and decomposition. Energy in, energy out. Now, another thing that we need to understand in terms of, just basic chemistry for our lab practices and stuff is solutions. So a solution is a mixture of some sort of solute dissolved in a solvent. And what we deal with in terms of solutions in the lab is when we're talking about lab media, or if we're making sort of like a drug mixture of a certain concentration, and that's all we really need to be aware of, okay? And the other thing about solutions that we want to be aware of is their concentration, okay? So if you have the concentration is defined by how much solute you have per unit solvent. And most biological solutions are expressed as a molar concentration or molarity. A mole is simply an amount of a substance. It's a base unit in chemistry for determining an amount. And 1 mole of any substance is equivalent to its molecular weight in grams. And I wouldn't worry too much about that. It just has to do with whatever its makeup is, whatever the compounds are, whatever the elements that make it up, have some specific weight of one in particular molecule. And the weight of a mole or amount of that molecule, if you dissolve that in 1 liter of liquid, then you have a molar solution. So a mole, we just need to know, is an amount of something, and we can dissolve it in a certain amount of liquid to determine a molarity. Most often in a lab, if I ever ask you to make anything up, or I might just show you this in a lab, when you're making something, whether if it's a solution, if you're making media, they make it very easy for you. On the container, they typically put what the molecular, or sometimes it's called formula weight is, and it just tells you how much it is. So this is 106 grams is what 1 mole weighs. So if I measured out 106 grams of that onto a scale and I dumped it in some water and dissolve it, that means my solution would be a 1 molar concentration. Okay? If I added more, it would be a stronger, more concentrated solution. If I added less, it would be a less concentrated solution. And for our purposes, that's all we really know. That's all sort of the basics of chemistry that are sort of underlying biochemistry. So in the next lecture, I'll give a quick overview of macromolecules and some important biochemical molecules.